Welcome to Solutions Part 3. In this part of the unit, we're going to be talking about different types of mixtures, including colloids, suspensions, and solutions, and methods of separation, how we can get solutions or mixtures apart from each other. So let's start with different types of mixtures. All three of the types we're going to be talking about may look uniform, but only solutions are truly homogeneous. Let's see if I can know that. The relative size of the particles is the chief criteria for distinguishing between these types of mixtures. So the first thing we have is a suspension. It's a mixture in which the particles of one of the substances are relatively large. So in a suspension, let's say you have some sort of solution and you've got some solute dissolved in the solvent. The thing about it is the solute particles are relatively large and they're just suspended in the solution. If you let it sit for a while, it's actually going to turn into something like this. So all of the particles are just going to settle to the bottom. Some examples I can think of in my head are something like chocolate milk. And I'm not talking about the chocolate milk you buy at the store, but the chocolate milk instead that you have to make yourself. So you mix the chocolate in and you stir it and you stir it and you stir it. And then if you let it sit for a while, the chocolate will just sink to the bottom of the cup. So if you really want to drink the chocolate milk, you have to drink it really quickly. Actually, anything that you have to shake before you drink it is going to be a suspension because eventually the particles will settle out because they're so large. So maybe orange juice would be a good example. And more science-y, I guess, blood is also an example. Blood will totally separate and into different layers based on the size of the particles. You can put blood in a test tube in a centrifuge, and it will spin it really fast and get the blood to settle out so you can pick out the parts that you need to study for whatever reason. The next we have is a colloid. A colloid is a mixture in which the particles are smaller than those in a suspension, but larger than those in a solution. And a colloid will exhibit the Tyndall effect. And the Tyndall effect is the fact that light will scatter when it hits particles of a certain size. So imagine, if you will, a cloud in the sky, and you see something coming out of the cloud, and it's like these rays of light. Rays of light coming out of the sky, and you can imagine some heavenly being going, oh, and just illuminating something at the bottom. But the reason why you see rays of light coming out of a cloud sometimes is because of the pollution or the dust particles that are in the air. The light will catch the dust particles in the air and it makes it look like there's rays of light coming down from the sky, but it just happens to be that that's where the pollution is. So, for example, something like smoke. Oh, that's a hard color to see. Let's try a different one. Something like smoke or fog would be a colloid. Now in a solution, it's a homogeneous mixture in which all particles are the size of atoms or molecules or ions. So we've got really, really, really small particles. These really, really, really small particles are the same size as, let's say, the water particles. So for example, salt water or sweet tea. The sugar molecules or the salt Na plus Cl minus ions are as small as the water molecules themselves, so they are truly completely dissolved within the water rather than being suspended in the water. So in a colloid, the particles are a little bit larger and they can scatter light, but in a solution the particles are so small that it's truly homogeneous. You can't see through it at all, or you can completely see through it as if it was nothing there. Here's a picture of the Tyndall effect that I was talking about. We've got a light shining through two different solutions. The solution on the left, this guy, is a true solution. You can't see the light going through it, or at least not very well. Whereas in the other one, notice that it looks like a solution at the top, just like just like the first one did, but you can see the light going through it. You can see the beam of light, which tells you that this guy is a colloid. So the particles are just a little bit larger. It's not going to settle out, but the particles are just a little bit larger that they can catch light. Okay, the next thing we're going to talk about is methods of separation, and I know we talked about this in Unit 1, and you can probably go back and watch the Unit 1 videos for this if my description here is not adequate, but it's the exact same thing that we've already done. So first we'll talk about filtration. That's pouring a solution through a medium in which only the solvent can pass. A solid mixture can be separated by adding a solvent in which only one of the components of the mixture will dissolve, and then pouring the resultant through filter paper. So I've got a funnel here with a piece of filter paper in that funnel, kind of like coffee. I'm going to pour the liquid through. The liquid will go straight through, but the solid will be caught in the funnel. Next we have distillation. In distillation, it's a method of separating mixtures based on differences in volatility or differences in boiling points. Substances that have weaker intermolecular forces will have lower boiling points and will be collected first. So let's just say you had a solution here of alcohol and water. Now we know that alcohol has much weaker intermolecular forces than water does. It's a whole lot thinner and evaporates a whole lot faster. So if you put just a little bit of fire here, not a whole lot, the alcohol would boil away. And so then we've got alcohol gas particles. And they have nowhere to go because they're stuck. So those alcohol gas particles kind of go around in here. But then there's water going around them. In this little tube, the water's going around them, which is going to cause the alcohol gas particles to condense, which is why this is called a condenser. And the alcohol gas particles are going to turn back into alcohol liquid particles and drip, 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 and you end up with alcohol in your beaker. Since the fire was not very high, the water doesn't boil, and if the water doesn't boil, then the only thing in your beaker is the alcohol and not water. So you can separate the alcohol from the water. And the last one that we're going to talk about here is chromatography. It's when a solution is dissolved in a fluid that will carry it through a stationary phase at different rates. So in paper chromatography, which is the lab we're going to be doing pretty soon, the paper used is made from cellulose, which is polar. This means that polar substances in the solution will travel more slowly as they're interacting with the paper, and the nonpolar substances will travel quickly because they're not interacting with it. So let's just say, for example, you took a couple of different kinds of marker. Maybe you took a Visa V marker and put a black dot there, and you took a black Sharpie marker and you put a dot there, and you took a black, Bic pen, and you put a dot here. So then you take that piece of paper and you put it in a little container of water right up to the black dot. And if you let it sit for a while, the black dot will disappear, and all of a sudden it looks like it's moving up the paper. And as it's moving up the paper, there's other colored dots that are left behind. And the black kind of completely goes away, and these other colored dots are left behind. Which tells me that these are the different colors that were mixed in these different markers. So your black Sharpie marker has, let's say, green and purple and red in it. And your black Bic pen had yellow and green and blue in it. And your black, what was the first one? Original marker had red and purple and blue and yellow in it. So it's like those are the components, the ink components of the marker. And also you can tell that the red is more polar because the red is closer to the bottom, which means it was interacting with the paper, and since it was interacting with the paper, it didn't travel very quickly. But the yellow at the very top must have been the least polar or the most non-polar because it wasn't interacting with the paper very strongly. It was just moving straight up the paper like it was running away from the paper. And that's chromatography. That's all we got here for methods of separation and types of mixtures. I hope you join me next time.